Our next speaker is Dr. Yasser Elshayeb. He is my colleague in Cairo University Faculty of Engineering. He's the chief partner of the Center of Excellency for Water, USAID Fund. Dr. Yasser is a graduate Cairo University. Dr. Elshayeb have been active in teaching and research. Since 2006, Dr. Elshayeb was highly involved in the setting of Euro-Mediterranean policies. Dr. Elshayeb has developed a passion for various fields of science and knowledge. And the title is Why Water Energy Food Nexus, a Data Analytics Point of View. Please proceed.
Yes. Good morning, ladies and gentlemen. Good morning. It's a pleasure, of course, to be here to speak to you about this important topic of the water energy food nexus. Let me start by thanking Professor Ala Zawahri from Cairo University, my alma mater, my original university. I work now as the Chief of Party Director of the Center of Excellence for Water at the American University in Cairo. I think the presentation is lost, yeah.
Which one?
Yes. بس المشكلة اللي بعد كده في ده. البرزنتيشن بتاعتي كده.
دي تمام؟
ماشي.
تمام؟
لا دي مش بتاعتي. It's not mine.
فين حضرتك
البرزنتيشن بتاعتي. أنا بعتها امبارح بالإيميل. مش موجودة؟ طيب. ينفع أبعتها تاني بإيميل دلوقتي؟
لا.
مش موجودة. أنا أقدر أبعتها تاني لو عايزين.
بص أقول لك حاجة، أنا ممكن
تعرض على
It's as you wish.
طب خلاص
أنا هبعتها دلوقتي حالا دلوقتي.
يبقى تقول على
Sorry, we have a technical problem. It will take 2 minutes, okay? Just be patient with us for 2 minutes.
And since I will be speaking about data analytics and data analysis and computers, so I'm used to those technical problems. Don't worry about it. It will take a few seconds, maybe minutes to finalize. ابعتها لمين؟ ابعتها لأني عنوان.
اوكي.
ابعتها عنوان. ابعتها ايميل. اهي. فورورد. لمين بقى؟ ابعتها لمين؟
مش احمد اهو، او افتحها ممكن حضرتك تفتحها من هنا.
ايوه انا هبعتها دلوقتي بالايميل. لمين؟ مين العنوان اللي هبعت له بالايميل؟
حضرتك كنت باعتها لمين؟
انا كنت باعتها امبارح للدكتور علاء وعمرو وكل الناس. هم دول وليد الحقيقي وايمان سيد وعمرو فوزي. برضه على الثلاثه دول. طيب وليد.
انا هجيب على فلاشه حالا.
الحقيقي.
ما دي مش ظاهرة ليه؟ هي دي دي هي دي اوكي.
So, back again. I'm actually very happy and delighted to be here for this session, where I will try actually to take you to a macro level, a bird eye view of the water energy food nexus. And I entitled my presentation Data Analytics Point of View, because I want to speak about the problem from a data point of view, not from a technical point of view. Water energy food nexus is a for me at least, is three gears that has to be articulated together, has to be working together. The water gear, the energy gear, and the food gear. And I will start actually in the reverse order. So I'll speak about the food and the need for the food. Then I'll move to the energy and the need for the energy. And then I'll finalize with the water and the need for water. Food is very much related to population. I mean, if you look at the Sustainable Development Goals, the 17 goals, you will find that reducing hunger is the second objective of the Sustainable Development Goals. So in the world, we have a population growth. Those are the data that we have on the population growth. As we speak today in this world, we are about 7.8 billion inhabitants, and we are projected to reach 10.9 billions in the year 2100. So in 80 years from now, we will have more than 3 other billion inhabitants on this earth. And this, of course, puts a lot of pressure on those who are working in the food sector, because we have to provide food for those people, and we have to provide not only food for those people, but also food for those who are currently now below the level of hunger in the world. This slide shows maybe a smaller zoom on the population growth of the world. We are here. I put it here in the form of continents, so the major continents that we have, and we see as well the development of the population. I'm using this graph to say that we need to work fast and work extensively in providing food for those people that we are producing as humans on this planet Earth. This is another graph just to show that in how many years do we double our population. And believe it or not, as we speak today, in 49 years from today, our population on this earth will double. So it's also another level of complexity that we have to take into consideration. Now, is the food industry coping with this increase? This is a question that we need to ask, because if we are not producing enough food for this population that we have on Earth, then we have a major problem. So the question that I'm asking here is, are we producing enough food, or are we able to produce enough food for those population? And the answer is more or less yes. I mean, if you look at this graph, for example, this is the maize production all over the world. I'm not speaking about a specific country or a region. This is the maize production all over the world from the year 1960 until 2018. And you will see that the production of maize, for example, have moved from 200 million tons to more than 1 billion ton in 2018. So 5-folds. If you compare that to the population increase, you can deduct that we actually have enough food to feed those who are increased in the population. The same graphs, more or less, you can see it in other crops. In wheat, we're speaking here about wheat. So the wheat production is moving from more or less 200 million tons again to 700 million tons. And here we have the cereal as well. So I've just brought three major elementary food inputs, and we see that from a food point of view, we are actually able to. And I'm speaking about the world. I'm not speaking about a specific region or a country. We are actually able to cope with the population increase, and of course, with maybe more technology, we can do better. This is a graph about the meat, because I spoke about vegetables, now let's speak about the meat production. And the meat production is, well, less than the vegetables, less than the seeds, than the maize or the corn and the wheat. But when we speak about meat production, we are also moving from 100 million tons of meat production in 1970 to more or less 300 million tons in the year 2018. So it is less than the development of the population, but it's still growing. There is a potential to grow in this sector as well. Now, let's take another aspect of the equation, energy. And I have here only one slide that speaks about the energy production in the world. And the energy production in the world as well is moving fast, is growing, is moving from 400 terawatt hour in the year 1960 to currently 160,000 terawatt hour in the year 2019. Of course, I mean, we can debate and we can speak a lot about the distribution of this power, where this power is being produced. Is it produced from a clean source or a non-clean source, renewable or sustainable, non-sustainable, and so on and so forth. But the fact is that the whole world today is able to produce, I would say, enough energy to supply this population increase that is happening rapidly right now. Now, where the problem comes from? The problem comes from actually from the bottom of this equation. As I started at the beginning, water, energy, food. So from a food point of view, we are able to produce. From an energy point of view, we are able to produce. But from a water point of view, actually, this is where the big problem is, and we are not able to produce. And this is where there's a lot of optimization to see. Let me show you the numbers. On the right-hand side, this is a graph of the whole Earth, and a photo of the whole Earth. And in this photo, you will see this is the planet. In here, this is the portion of water that we have on the planet, and this is actually the portion of the usable water that we can use. And then there is a small point here, which is actually the water that we have in lakes and in rivers on the planet Earth. And on the right-hand side here, you have all the statistics that speaks about it. So as an amount of water that we have on Earth, we have actually a limited amount of water. Maybe it's not evenly distributed. Maybe there are regions that have more water than the others, which is, of course, we know that. But the major message, or the main message, is that the amount of water that is on this Earth is actually limited, and there is no room for more of that. This is the water usage that people use also all around the Earth. And there is a development. But you can see from this graph that the rate of development is much, much less than energy production, than food production, and of course, than population increase. So more or less, sooner or later, we will be facing a major deficiency in the water share per capita all over the world, whether we like it or not, whether we have it today or not. Now, I'll move to this very alarming graph to show you that this is the portion of fresh water, or the share of fresh water that a population, that a person in a country in the world has. And you can see, of course, I mean, from this graph, it's very clear that the red color is about Egypt, Libya, Sudan, maybe some other countries in the Middle East. But there is a problem here because, again, this is a region where the population is growing, the need for food is growing. Maybe you are able to cope with that. The energy consumption is growing. And again, we are maybe able to cope with that. But the problem lies again with the water. This is where I say that we need to really to take care of that connection between the water and the energy and the food. And I, as an engineer, as a professor of university, I would say that it is actually a problem of optimization. It's not a problem of production. It's a problem of optimization. Maybe with the technologies that we are using today, with the technologies that we are actually employing today, we can have a different usage for the same water. Maybe we can have a different mechanism to clean the water that we have on this earth. Again, the message that I'm putting here is that it's not a luxury. It's not. I know that it came into science maybe after the year 2000, but it's not a luxury. It's a necessity. It's a necessity that we have this connection between those three sectors. And of course, today we have seen some of the presentation speaking about how can we involve private sector, how can we involve private sector, the policymakers, and even the wastewater treatment. All of this is actually within this context of we need to solve this problem. We need to attach those gears to each other in order to find a solution for that problem. Last thing that I would like to speak about is that we at the Center of Excellence for Water, we are very much concerned about the water energy food nexus. And actually we have a school, a winter school that will be starting it will be held between the 8th of November until the 17th of December this year. And our aim is to teach, is to train, is to have young professionals, young researchers from Egyptian universities, from Egyptian research centers, that they can come and learn about the water energy food nexus, and they can really practice their abilities. Our call for proposal is already on our website, and our chief scientist is Professor Hani Swelem, sitting here in the first row. So this is maybe one of our contributions to trying to solve this problem. That again, I can say that it's not a problem of population, it's not a problem of energy, but it is actually a problem of water because of the limited amount of water that we have on Earth. Thank you very much. I have nothing more to say.
لا مش هحتاج. Okay, thank you, Dr. Yasser. Thank you very much.